This is Chapter 4, Section 1, Problem number 25. The data in the table to the right are based on the results of a survey comparing the commute time of adults to their score on a well-being test. Complete parts A through D below. Okay, so they give us the data here. Which data is likely the explanatory variable and response variable? The response variable is a variable so it can be explained by the value of the explanatory variable. In other words, the response variable is the dependent variable, while the explanatory is the independent variable. Another way of looking at it, the response variable is the output, the explanatory variable is the input. Commute time, the input in this case is the commute time. Okay. The output is going to be the well-being, because that's the response variable. Then they ask for a scattergram of the data. So for a scattergram of the data, we can go ahead and select here, and you open it in StatCrunch. And then go to graph, and then scatter plot. Click on scatter plot. X variable is commute time. The Y variable is our well-being score. Then we select compute for our graph. And there you can see the graph. And then you can see the graph there, and there's our graph. Determine the linear correlation coefficient. So we can do that using the data. Again. So I can go for part C, I can go to StatCrunch and select Stat, and then go to Regression, and then Simple Linear. Okay. And my X var is the commute time, my input. My output is the well-being score. And then select compute. And it gives you the data there. For my R, correlation coefficient is a negative 0.978. Okay. It gives us the strength of the association appearing together. Doesn't mean that one causes the other, just that they appear together. Example might be age and gray hair. They appear together, but one doesn't necessarily cause the other. Part D. Does a linear relation exist between commute time and the well-being index score? Compare the correlation to the critical value. If the linear correlation is greater than the critical value, then there's a positive relation. So if the linear correlation is greater than the critical value, so find the critical value for n is 7. There's the for critical values are there. N is 7. So it's 0.754. Okay. In this case, the absolute value of the linear correlation is greater than the critical. The absolute value here. To determine if a relation is positive or negative, determine the linear correlation coefficient is positive or negative. The linear correlation coefficient is negative. Use the previous to determine if a linear correlation exists. So you can see right there. So if the linear correlation coefficient is less than the negative of the critical value, then there is a negative linear association here. In this case, they tell us that it's greater. So we have a positive linear association. Close. And